This is the next part of visualization of 3D objects, in which we'll study about surface development. So in the surface development, also called as folding and unfolding, the reason being we'll see the meaning of the word surface development. We'll also try to understand that. And the concepts that you have previously studied, like counting the surfaces and visualizing any 3D object, those concepts will help you in this part also. So first of all, again, let's look at the surface development and our exams, NATA JEE. First, if I have to explain what a surface development is, I would say that you have a 3D object and then you unfold it. It's like you have a box, you unfold it, and you have papers like that on a 2D plane. So that is a surface development. So we can say, you can say it as unfolding, or you can say unrolling. Any word you can use. Of all the surfaces of an object on a plane. Basically, you are having a three-dimensional object and then you unfold it and you get all the surfaces of that object on a plane. So this topic, the surface development, is also very important for NATA JEE. The reason being same, you can expect on an average 1 to 2 questions, or 3, can go more than that also. Like in some of the previous years, but we saw that these exams consecutively ask 3 questions back to back just on the surface development part. We have seen that trend also, but now just to include a lot more topics in the exam, they restrict themselves to only 1 or 2 questions from any particular head. So you can expect on an average of 1 or 2 questions from this particular subheading. And in this, we need to understand the 3D object that is given to us. So like in the previous topics, in the previous classes that we covered, this is the requirement that was common in all of them, in which you need to understand the 3D object so that you can actually see what is happening. And then you need to visualize how it will look like when you open it up. Visualize to the unfolding part. It's like if I show you one image. So we have a cube. This is our object. The surfaces start opening up. The top part goes like this. So this is opening up, the base opening up, the sides are opening up. And then after this, you can see that this is the sheet of it. You can simply think of whenever you bought a cake or something for your birthday, so it comes into a box like this, right? But this box is made by such kind of layout. All these surfaces, they are having those kind of additional shape. Surface development. So such kind of things you will see in the exam. You will get a 3D object. They will give you 4 options which are having options like this, and then you need to identify which one is the right one. Are we clear till now?
Yes, sir.
Okay, others?
Yes, sir.
Okay. So in your exam, you will get the 3D object like this cube. You will get 4 options like this. If I just erase these things, 4 options like this. You need to observe this figure as well as the 4 options. Sometimes just observing the option, you will get the right answer. We have another type also, that is the paper folding and cutting. So will cover these two one by one. First, as till now you guys are familiar with a lot of 3D objects when you counted their surfaces or the vertices, or when you counted the blocks. So let's look at some of those. This is your prism, or you can say your cuboid. And this is what you can see the surface is developing. You can say this face went like this. This is opening up here. This side we are having these two surfaces, this one and this one, because we need to cover the side and the top. And then we have another one on the back. Then we have something on the base which is not visible to us. So similarly, if we are having a cylinder, that means we are having two circles on the sides. Then we are having this paper rectangle that is folded to make the cylinder. So if someone asks you that what would be the surface development of a cylinder, you can simply say that it would be a rectangle having two circles on the sides like that, so that this paper can fold itself into the curved surface part of the cylinder, and then these two attached circles can make the top and bottom of it, right? On the similar manner, you can look at this square pyramid. So this is the base that we are having. This is the one side, and these two attached are on the next two sides. So from this one thing that you can see, all the different parts of any developed surface would always stay connected. It's like if I take the example of this cylinder only, so it will always stay like this, a rectangle and these two circles. It will never be like this. There won't be any gap, never. All the surfaces, they will always be connected. Like in the yesterday's class of counting blocks, all the blocks were connected. So just go through all these 6 images and see if you can understand how the surface is developing. We have seen the tetrahedron case. So we are having the base, and then we are having these triangles which will cover up all the sides. So is it all clear to you guys till now? All these examples
Yes,
that
sir.
I'm showing here.
Yes, sir.
Okay, so now as we have till now understood what kind of 3D object we can see and what is a surface development is, but in exam we'll get some more complex forms. So we need to understand how to solve those kind of questions that we'll get. So for this, in this main what it says that in one of the option, when you fold the surfaces, like you turn them on this side, you use these cutouts, and then you fold, you will get this figure. So basically you need to identify which option will give us this figure, right? And all the lines that you are seeing here, like this much of section, then this section, then this small section. This side and the opposite side, these two.
So the first one, sir.
So if we look at this type 1 and we want to know the methods to solve, so first rule that we need to keep in mind is, in the question figure, this one, and in the correct option, all the dimensions will be equal. It's like if this element is only this much of height, then in the option the element would be of same height, say only this much. The height will remain same, the proportions will remain same. So this way you can actually differentiate between the given options. If an option is having some size that is not equal to the given question, then that would be the wrong option. So first one is, we can say length of lines would be equal. Lines and surfaces. I'm saying surfaces because you see the top part of it. So the size of this surface will be same as in the option. Say if this is the top surface, so both of them would be of same size. So this will be same. You can just note down these key points that I'm telling you, which you need to keep in mind while solving the questions. Then second method of solving such questions is, you see these two branching. These are basically the sides of any 3D object. This side and the opposite side. After that, it's basically one big rectangle having these different cutouts as per the folds of it. As per the folds, these folds go. So always unfold the sides first. And then remaining part. That means always first compare these sides. There might happen that out of the given 4 options, 1 or 2 will simply get eliminated because these sides are not what are given in the question figure. After this, very important part, the third point, that is, I would say, very important, because this is a method of solving these questions efficiently and accurately. And that is, see what happens is, when you develop any 3D, when we open up this, we don't know from where they have actually started opening up, right? They can start opening this 3D from this point, they can open it from this point, and then they can generate the options. So we don't know from where they have actually opened the 3D figure to develop their surface. But one thing that we know is the number of surfaces would be equal in the option and in the question. That means if you count the surfaces, like 1, second on the back, third on the bottom, then 4th, then this 5th, 6th, 7th on the bottom, 8, 9, 10, 11 on the bottom, 12, then 13 this side, 14 opposite side. So the right option will have same number of surfaces. Our question is having total 14 surfaces. So the answer would also be having 14. Simply count the surfaces then count the surfaces in the option, and whichever option does not match with the number of surfaces, simply reject them because they would be the wrong answers. So this is very important. Count the surfaces.